Hello. Now, welcome to RINF TECH. I'm glad you guys are here. I love the turnout. Thank you very much. Let me introduce myself. My name is Jacek Korzyca. It's a Polish name, so it's complicated. I am aware. I'm a head of pre-sales at RINF TECH, and this is the department that bridges sales and technical areas. I'll be the announcer today, pretty much. So I'll be walking around announcing my colleagues and and hopefully answering some questions or helping you out as we go. We'll have 4 speakers today. First will be our CTO, Dragos, with a short speech. And then we'll continue with 3 other speakers, and we'll be talking from generally high-level IoT, how we see it, and how RINF TECH IoT is done, through more technical aspects. We'll have a live presentation you'll see with our robot. And last but not least, presenting additional sort of software IoT solution. Good, welcome, and I'm glad to have you. Let me start with Dragos.
Hello, and welcome to RINF TECH. I'm Dragos, I'm RINF CTO. So RINF TECH is a multi-branch company, very, very focused on engineering, and this is what we want to share with you today. I don't know if you can hear me well. Okay, so we are located here in Bucharest with our main development center. We have also other delivery centers in Bulgaria, in Ukraine, and also sales presence in largest European capitals in London, Paris. What I want to share with you today is our vision and commitment to robotics, IoT, artificial intelligence on top of everything. And with this respect, I would like to share more with you about our technical center here, our R&D center that we have here on the floor. So we currently operate a robotics laboratory that, of course, you can visit later on. We have multiple teams that are currently focused on embedded development, hardware integration, software to hardware, and multiple platforms of software integrated with various types of interdisciplinary hardware platforms. So what we want to share with you today is our research in these fields, and I would like to let my colleagues get you on board on this journey. Thank you very much.
We're starting now with our colleague Stefan, who will be giving you a little bit of an overview of how we see IoT, how we define it, and what does it mean to RINF TECH. Go ahead, Stefan, come over.
Hello everyone, my name is Stefan Anditsu. I'm the AI solution architect here at RINF TECH. Today I'd like to talk to you about IoT, what it is, and how it impacts your life, and why should you care about it. Basically, the internet has undoubtedly been one of the most important innovations of our modern age. It's changed everything from entertainment to how we work, to how we shop, and how we communicate with each other. But it has mostly been content created by people for people to use. So people communicating with each other, people creating books, text, media. It is an internet of people. So what is the Internet of Things? Well, it's exactly that. An internet of things. Things creating data for other things to use. And once these things start to accumulate data and communicate this between each other and share their experiences, they can learn from each other's experiences and improve their overall capabilities. And once these things pull all this data together in the cloud and analyze it with advanced software, with AI, with statistics, they can change our world in a lot of ways that we've never previously thought about. Basically, all these things connected become then a system of systems and improve our world and our businesses. IoT has quickly been started being adopted in a lot of domains. We're now seeing it in agriculture, manufacturing, healthcare, retail, energy, automotive. It's changed basically every sector and every industry we know today. What can IoT do for you? For example, let's take an example. For example, self-driving cars. According to the National Highway Traffic Administration of the US, 94% of motor vehicle crashes are caused by human error. This is largely due to to drivers being individual agents on the road and have to rely on sight to see and predict what other cars and hazards on the roads are doing, what are other drivers' intentions. Yeah. So basically, for example, the car in front of you brakes, you have to also brake to not crash into it. You see a patch of icy road, you have to swerve to avoid it or adjust your speed accordingly. So it all relies on human sight and reaction time. State-of-the-art computer vision software has greatly, and autonomous cars have greatly improved this statistics, but they still rely on actual seeing the hazard and predicting a course of action to avoid it. This has increased the reaction time, but it still relies on predicting your environment and other drivers' intentions. But what if cars communicated with each other? So every car knows the intentions of all cars around it. Going to our previous example, the car in front of you brakes. It immediately sends a message to your car to do the same, to not crash into it. Or the car 1 mile in front of you detects with its sensors, with the sensor in its tires and so forth, detects a patch of icy roads and adjusts its speed accordingly, and also notifies every car 10 miles behind it, hey, there's a hazard on the road. Basically how people do it in ways, but directly automatic, and with the data from sensors in the car, so way more reliable. So if that would happen, there would be less accidents, no need for traffic signs, for traffic lights, because what are traffic lights then a way for drivers to communicate with each other without actually speaking to each other. Basically, I have a green light, you have red light, that means I go when you stop. But the cars can communicate with each other and hugely decrease traffic incidents. There would be no need for speed limits, because speed limits are basically calculated for reaction times, and autonomous cars have an instant reaction time as opposed to humans. Now, why should you care about IoT? So, according to a research report from Bain & Company, the overall IoT and analytics revenue in 2021 is going to increase to 520 billion, a huge increase from 2017's 235 billion, almost double that. The second reason, one of the most important and hot topics right now in tech is AI and machine learning. But what is machine learning other than... so machine learning is basically a machine trained to analyze huge amounts of data and find patterns inside that data. And what is IoT? Then just a huge data producing factory. Now, there are a lot of challenges with adopting IoT in your company, in the industry. One of them is a common language. Just like humans need a common language to be able to speak to each other, so do devices. Because what is data than just a bunch of ones and zeros transmitted over a wire, basically electrical impulses. And you have to make sure that the electrical impulses sent by one device to mean something are interpreted in the same way by the receiving device. And just like human languages, there are a lot of things languages out there. These are called communication protocols. And there are efforts by a lot of companies and non-profit organizations to standardize these languages, just like we're trying to do with English, for example, so more things get to a common language and are able to speak to each other. The second, actually, just as important aspect and challenge is security. Because with that amount of data circling back and forth over a network, you want to keep all these data away from prying eyes. So you don't want people to be able to access your car when you're on the road and stop its motor, which has been shown to be able, hackers are shown to be able to do that. Or you don't want banking informations, someone listening to banking informations that devices are exchanging between each other. So that was basically a high-level overview of the entire IoT field. There's a lot more to say there, but that's mostly what we have for today. Questions?
I have a question. My question is, what's the speed of adoption of those devices you talked about? Because you mentioned there's a lot of devices, there's cars and so on. Yeah, but I don't see so much in my car now, not yet. So I'm curious, how do you see the speed of within the time?
Well, thanks. So basically, each industry has a different level of adoption. For example, for the car example, these need to pass through a lot of security and security protocols and legislation. So here, it's gonna be. Germany has predicted that by 2040, half of cars in their major cities will be autonomous cars. But that is just one prediction looking at the trends, so not necessarily. On the other hand, on small edge devices, so for example, smart homes, smart cities, we've seen with in Alba Iulia here a lot of improvement on that. A lot of people adopting, for example, my refrigerator is connected to the internet. I have never used this connection, but it has that capability. Televisions, now we all have smart TVs, which are no different from your laptop or phone. So basically a television is just a large tablet, which is just a larger phone. There is an estimate that by 2020 there's going to be around 1 billion IoT devices. So devices that are able to communicate over the internet and share data. These devices being everything from smart cars to low-level appliances that, like my refrigerator. Does that answer?
Yes. Any other questions, maybe? Anyone?
Sure.
Are there any challenges besides the security side? And I would like to know if there is any other challenges besides the security, and what will be the main challenges to be sure that all those IoT technologies will be implemented in our daily life?
So basically, there are a lot of other challenges, like the fact that you need dedicated hardware for this to do this. So either buying it directly with the devices implemented, like smart TV, smart toaster, or there are efforts from major companies to help developers integrate chips that are able to do this. But yeah, the most important challenges, I think, it's security, because as I said, for important information you don't want someone else looking at yours, and that standardization. So basically, it's just like human languages. For example, you speak French to me, I understand, I hear the words, but if I don't know the French language, I don't know what they mean, but I do hear the words. So it's exactly with devices.
Just to add something. So as far as I know, another challenge is related to infrastructure, because basically if you have like billions, because there will be billions of IoT sensors, you need 5G, for instance, because you need low latency transmission, high bandwidth infrastructure. So this, when 5G is going to came on the market, I think the IoT market, it will explode in that moment.
Yeah, and not only the infrastructure, but as far as you go, infrastructure has a lower increase than actual software. So even if you do increase the infrastructure, then the demand is just going to increase. So you also need software for load balancing, for managing traffic over the internet, especially if you have 1 billion devices all talking at the same time with them. And this also goes back to country legislations. So basically, in a lot of adoptions, I think the main obstacle is country legislations and laws getting up to this. As we've seen with Facebook and data analytics right now, laws did not keep up with the technology.
And same even for autonomous cars also?
Sorry?
Same even for autonomous cars, because we know that one of the main challenge for introduction and high penetration rate of autonomous car is the fact that in the States and in the European country, we have a strong debate on the responsibility in case of accident.
Exactly.
So
as I said, there are differences between fields here, because if my smart TV crashes, that doesn't matter too much. But if my smart car crashes on the highway, then that's more of a problem for me. Or a smart plane, exactly. Well, Dubai is trying to implement, the Uber in Dubai is trying to implement smart helicopters with autonomous helicopters for this, for the type of Uber. So there are a lot of challenges, but the main obstacle in adoption is laws and legislations, especially for banking, autonomous vehicles, stuff that poses serious threat or importance to our security and safety.
Any more questions? No. Let's maybe try the second part of the presentation. Okay.
Now I'd like to speak to you about some of our efforts here at RINF TECH. So one thing that we're working on is not so much in creating IoT applications, but enabling the back end of IoT, basically helping and enabling other users to create IoT applications more easier. So the question is, how do you get from, for example, in a warehouse, reading the temperature in a warehouse to sending that data in a cloud, analyzing it, and then sending the command back to a thermostat to adjust the temperature. So basically, how you get from a sensor to the cloud. The sensor basically reads reads raw data, just reads the temperature in the room. You would need then for something to interpret that that data, those electrical inputs, and transform it into a data that the computer registers. A microchip can read. And those are what drivers stand in for. Then on top of this, we add the I/O input-output communication library, because there are a lot, as I said, there are a lot of protocols: GPIO, I/O, PMW, PWM, and a lot of protocols. And on top of that, you add another high-level abstraction library, so the user works directly with a sensor, for example. It says LED on or off, or read temperature. He doesn't need to actually read the gibberish that he then has to interpret. And then afterwards, that moves to your application, and the application is responsible for sending that data to the cloud. So basically, the data goes from being a temperature, a physical value in the world, to data on the cloud through different steps. And the one question is, why have all these separate modules like this, all these separate libraries, and not just have one continuous, one single module that just reads the physical temperature and sends the data to the cloud? Basically, we keep it modular like this. Like, for example, if another company creates an IoT device which does not read the temperature the same way that our device reads it, but does not want to implement the full stack, basically he can just come and replace that module with his own module. Or maybe he creates a board that uses our board. So basically all the software stack is identical to ours, but wants different functionalities on the high level part. Basically replace that module. It's basically like Lego pieces. As long as the ends fit, you can replace it with whatever you want inside and achieve custom functionality. So that was our presentation on what our efforts right now are here. Any questions on this part?
If we don't have any questions, then I wanted to thank you, Stefan, for the presentation. Thank you very much. I think we went a little bit quicker than expected. I think we can move on to discussing our Mqtt robot, and I will invite our robotics engineer, Mihai. Go ahead. Hello.
Hello.
Here we go. This is your remote. Come maybe up front.
Yeah. Thank you. So I'm Mihai Crăciunescu. I'm in charge of robotics lab here at RINF, and one of the product that we design it's Mqtt. What you see here before I start, it's the first prototype that we had. Now we're working on a Mqtt version, and actually we are building it in the lab. So if you want, after the presentation, you can come and see the labs and the lab and also the robot. So before I start the presentation, I will just briefly discuss about Mqtt for the persons that don't know exactly what Mqtt does. So we design a robot that can test any device, any touchscreen device, from phones, tablets to touchscreen in automotive areas. So let's start. In this presentation, I will go through the steps needed to actually design this robot. Everything here was designed in-house and built in-house, from the hardware itself to structure to PCBs and the software. So before starting building the robot, you need to do a 3D design or 3D modeling of the robot. This also helps us to create new versions. As we see here, we started with this on left, which is the robot that you see there, and now we are at second version, the version that is built now in our laboratory. And with the 3D modeling, you can spot a lot of things that cannot or don't match very well with each other, and you can change them and you can modify the robot before actually you build it. Also, the simulation or the 3D design is very good for simulation, so we can simulate or we can test how different parts perform on certain forces applied on them. And also, for example, we have on the new version of the robot 2 cameras, and we tested how the field of view of the camera will or how should we place the camera for the field of view to see the entire scenery of the robot. So after we do the 3D design, then we actually, where are some sensible parts that we want to double check before actually produce them, we 3D print them, and as you can see here, it's an assembly, the effector used for the fingers. We actually create this version, and we play around with the components, and if we are happy, then we'll produce them from material. In this case, it's aluminum. So basically, every single part goes from the design to actually producing them. Also, the same steps goes for the electrical design. So here is just a simple schematic. The new version of the robot has around 8 PCBs with 8 electrical schematics, different electrical schematics. Here is just one for the Ethernet port and some I/O ports. Again, every single chip and every single let's say area is designed in-house. After we have this, we actually create the PCB itself. After we have this, let's say this blueprint, the PCB is sent to China or another country to be manufactured. And then, of course, we also do a 3D design of the PCBs, and we'll go back to the simulation that we had before and see how the PCB will fit inside the robot, and if there are any clearance problems or things like that. If we are happy, then we'll go further on and we'll mass manufacture them and also put the components on the PCBs. And to link Mqtt with IoT and what are our next plans for the robot, firstly, we want to be able to do maintenance on the robot. So basically, I put some flames because I think every presentation should have some flames in it. If, for example, the robot will have some issues from some other reason, maybe hardware or software, or we don't know, we want to know, because this problem can be for every single unit that we produce, and we want to know in order to fix it. And then, of course, we can do different software updates on the robot if needed. And also we can do analytics and data logging. So basically we can know, for example, how many meters or kilometers does the effector or the robot moved, and then we can recommend changing some parts, or we can know how much power did this robot use in its lifetime, things like that. So that's one part. The second part, we're thinking to have platform as a service or robot as a service, if you will, in which we can hire in a way, or we can create some connection in which somebody from another country can connect to the robot and actually do the test on an actual device. So below you can have your phone or your tablet or what you need, and then you test how your software will perform on that tablet. And this connection will be done by internet. And also another idea that we are working on is to have collaboration between robots. So basically imagine a scenario in which a robot will call a phone that it's fixed on another robot, that other robot receives the phone call and do something, or send an SMS, read the SMS, sends back an SMS, things like that. So basically the robots can can communicate with each other, and you can have a big robot farm that will do a test together. So that's basically from the robot point of view. If you have any questions, please ask. And after that, we'll do a live demo with our robot. Thank you. Yeah.
So, if I understood correctly, this robot is used for testing an application on a mobile device, right?
Not only, but can be
You
used.
can
Yeah, exactly.
test for onboard computer from a car, right?
Exactly.
I don't really see the point, because you can test a mobile application through ADB shell. An onboard computer from a car you can test through connection directly to the data bus. So, and it's way more simpler to do so, rather than performing OCR over the screen and then pushing physically the buttons.
Yeah, if I can answer. We not only produce, so basically we don't use any OCR yet. This is not what interesting us. You say the ADB. When you use iOS, you will have a problem, and some of our clients are interested into using the robots for iOS platforms. And in car manufacturing, is not only clicking buttons. They are actually interested to test the hardware itself. There's another software that runs on the hardware, but the hardware itself, to see if, for example, if you click at a certain position, the pixel lights up at that specific.
You mean stress testing the display?
Not only stress testing, but actually the calibration part. So basically, you have the touch foil, and underneath you have the screen itself. And when you touch the touch foil, the screen should light up some pixels, and those can have an offset. And you want to calibrate this when you manufacture the screen itself. So from a hardware point of view, by testing your device, you can assure the same consistency. Exactly, that's the word, for all of your devices.
Yeah, but still, this test should be done by the manufacturer of the display itself, because a car manufacturer will buy the display from Samsung, for example, and it will come with some certain specifications. It's supposed to be previously stress tests.
Supposed to.
Okay.
But we have actual clients that are interested in doing this.
Okay, thank you.
Thank you. Is there any other questions? Yeah, please.
Sorry.
No, go ahead.
Okay, so as a device tester myself, I feel kind of, scared of this robot and what can it do. So my question is, how far do you see yourself going into this project? I think, are we talking about interacting with the camera and see if a device shows a specific icon, if it sees what the signal is? How far do you think this kind of project can go?
Regarding what the colleague asked before, we don't do OCR, but imagine here that you'll have a specific, let's say, icon or a specific text.
Exactly.
We can take the snapshot of that text, and we can look if that text is present in the view of the camera or not. And our algorithm is really precise at this. So basically, we can recognize if a button is there, if an icon is there, where is that icon. So the idea here will be to automate a test. So automate a script, to have a script that says, okay, go on this icon, then click on that icon, and then find if this is around or not. And the robot can do the steps. And if you move the device, so basically you will have not an Android phone, but you'll have a tablet. Once you written a test, it can be applied on the tablet, so you don't have to rewrite the test, because the robot will recognize the icons using the camera.
Yeah, so for you to understand, the main problem in testing is when you do this test in a Faraday cage, any interaction, any human interaction influences the results. So this is my curiosity, if the robot can do the job better. You put the robot in a Faraday cage, and it does the job with no human interaction, and you as a human, you only see the results, and that's it.
Exactly. the test that you will see, it's for a client that wanted to put the robot on a Faraday cage and actually test the network itself. And a phone on 3G will call a phone on 4G, and all of the combination of phone on 4G will call a landline, things like that. And they wanted to use the robot for this.
Okay, thank you. The robot will save my future children from the radiation.
Yeah. Okay, so
Wait,
is
maybe
any
other
other question?
If no more questions, we will do a demonstration of how it works. You can stay seated. We'll transmit the signal through the camera so you can also see. Yeah.
So what we have here done for this presentation, we have two phones on iPhone X and an iPhone 6. Is the test for a client. And basically a phone will call the other phone, and we also send an SMS from a phone to another phone. The idea here will be if we have two different robots, the devices can be put on two robots, but for now it's on the same robot. So now the robot recognizing on the phone icon types the number. The recognition of the number is done with using image recognition, so it's nothing hard-coded. Again, now it's looking for a button that for now, yeah, I think doesn't see for the lighting condition, but we'll repeat the test. So again, should recognize the answer buttons, but I think due to the lighting condition didn't see it. And another one will be to actually send an SMS from the one phone to the other, and also they're using OCR to detect the message itself. This was one of the requirements that the client had. So we'll take just a few seconds to set it up.
Mihai, meanwhile, we have a question from online. Will the robot replace humans in the future? Will this robot replace humans in the future, actually?
Depending on the setup itself and on the test that might or should be developed. But if there are simple tests like this one, write a message, press some buttons, and have a linear motion or a predictable, let's say, path, then it might replace a human. So let's see. Now the robot is typing a message and should be sent on the other phone. Okay, so the message arrived. Yeah. So we'll try a little bit later with the robot. I think there's a problem with the camera itself. So again, to show that nothing is hard-coded. Again, on the presentation we had some small problems, but we'll fix it and we'll run the test in 5 minutes or so. Okay. Is there any other problems? Other questions? Sorry. The problems we have.
Hi.
Yeah.
Just for the algorithm, is it scale and rotation invariant, right? So
Correct.
If you rotate the display, it's okay. It can still recognize the object. And if it's bigger or smaller, it can be a TV or a phone. And
yeah, that doesn't matter. The image recognition, when it works, it's designed to be scale invariant and rotation invariant. That means that if you can put the device at any angle on the robot, doesn't matter exactly the rotation, and also it can be any size. So you can put a tablet or a phone and
only the physical constraints of the robot itself, what you can fit inside the...
Yeah, so for now, the new Mercedes will have a really big and wide screen, and we have to somehow fit it. So basically it's a really wide screen that it's in a way divided in two screens, but it's on the same console. and you have to test every single one. So basically, you'll put half of the screen here with.
Oh, so you have to break it in half, right?
Yeah, exactly.
Okay. I know it's Mercedes will agree, but
yeah. So
okay, thanks.
5 minutes, and we'll come back.
So we still have to wait a couple of minutes for restarting of the
possible,
okay.
yes.
Maybe you can comment. Maybe you can comment a little bit on the new version, what's coming up now.
Can we switch on the presentation?
Yes, let me switch back to the presentation. 1 second. Go ahead.
Okay. So this is the new version. Actually, we received the parts yesterday for this. Will be ready in 1 or 2 months. And the idea of this robot, we try to improve every single details from this one. We learn a lot from this version, and now we're working on new version. So what we've done here, we added more IOs. So we added more possibility to connect to the robot. We have some USB connection. We have an Ethernet one to be connected to the internet. And we have two additional cameras. So one is on the effector itself to see the screen, and another one that is not shown here. It's up that can see all the screens. Also, you can see all the areas of the robot. And also, we changed the materials used. We made it more stronger in a way, and yeah, we added more capabilities to it. We also changed the motors. For this one, we used some stepper motors, but for this one, we use servo motors for added speed. So this is the speed that this robot can move, and for some clients, this was an issue, and we tried to change the motors and add more speed to the robot itself. So in general, that's it. We basically added more IOs. We added the possibility to be connected on the internet. This robot didn't have, and we added different cameras than these ones. For this robot, we use some off-the-shelf solution with a Raspberry Pi that takes the video stream for the camera and then send it further to the laptop where the image processing is done. Now we try to actually use USB 3.0 connection directly to the laptop and remove the Raspberry Pi from the general architecture of the robot. Yeah.
Any questions from here we go.
So I'm not sure I understood the general use case. So you will connect the new robot to the internet, and the user will be able to use it, let's say, testing different devices. Do you plan to have like an application that will write the test cases, or how will end users use the robot? Because the user case would be they either use an app on the phone or a software that is developed by you, or how will you support this?
Okay, so basically it's really important areas. Now the robot, because it's at the beginning, now because the robot is on we just built the second version, and we will enter soon on the market with it. We focus mostly on automotive and also the areas for the developers itself, so the testing of the apps. The idea, what we are trying to do right now, is to create web platform in which you can design your tests, but the test will be designed on what you see is what you get. So basically you will take this picture and then you'll add an action to it. So you can add tap to it. And then you can create your test like a flow in which the robot will click on certain icons, that the icons have to be recognized by the robot. And you can go step by step in every single tab or what you need, and then, for example, you can say find this text field, and you give the image of the text field, goes click on it, and then write a message or something like that. You can give the message. So you can create your test in this manner. But for now, our focus is mostly on automotive, where the things are a little bit more simpler from this point of view. You don't have to have this platform, but we are working actively to have this web interface in which you can create your own test. And actually, we'll need some feedback from the community in order to have this as well as done as well as possible.
Does that answer your question? Okay.
Okay.
We have one more question online from Cosmin, who's asking why not remove the frame and just attach it to the ceiling?
Yeah, that's another type of Delta robot. So Delta robot can be done in this way, like a 3D printer, or can have the arms on the ceiling. It depends on the application. You can use, or you can create a robot like that, but mostly when you have underneath a conveyor belt or something that will move underneath the robot in order to have this area free. But for us, this was not a priority because the screens are mounted on the base of the robot, so we didn't need to do that. And from a customer point of view, it's a little bit more difficult to ask them to mount the robot on the ceiling than on the table. So that's why we designed it like that. If it's needed, then yes. So we are okay? Okay, good. Let's redo the tests. So again, nothing was hard-coded as you saw. We'll try it again. That's one of the problems that we had with the camera from Raspberry Pi, and we changed on the new version. So again, the robot types the phone number on the other phone. Now recognizes, see where's the answer button is, clicks on it, waits for a couple of seconds, then closes the phone call and go back to the menu. And the second test, in which we send a message and the robot will recognize that message, an SMS basically. Again, recognizes the SMS icon or the message icon, and go actually to write the message. It's something hello from Mqtt, and we'll send it to the other phone. So the robot has a finger underneath, a capacitive finger, and as we see, there's also a wire because you have to connect that finger to ground. Otherwise, the phone doesn't recognize the tap itself. And once the test is written, we'll send to the other phone. And the robot should detect an incoming message. So basically that area on top. Once it detected, goes to message icon, to the last message received, and we'll try to recognize using OCR this message. And after everything was done, the robot will close the application and can do different movement for a fine iPhone X than an iPhone 6. So you can close the application different way on every single phone. And that was the test. Are there any questions?
Go ahead.
So, in theory, this robot could run 24 hours a day,
Yes.
7 days a week, but speed would still be an issue for it, right? Depending on what it's testing.
Yes.
The faster, the better.
Yeah.
Okay.
And this is what we are changing to the new version that you are invited to see. We are actually building it right now.
All right, and for the typical, your typical customer, or the use cases from your typical customer, how long do those generally run currently, the test scenarios?
So from what we saw right now, it was not a problem of timing, but more of a problem of precision. So how precise your robot is in order to see if an icon is at a exact position where it should be, or if I click here, does the screen show me that I really click at this position. So for now, the speed was an issue because as fast as you run, then the test will be shorter. But more important was the precision of the robot, not the actual speed.
Okay, and so am I testing, or are you testing a single component that then will act as, well, if this passes, thousands of components pass, or are you testing, or are you envisioning a scenario in which thousands of components are going to be tested?
That's depending on the use cases, and that's depending on the client itself, but it can be used either way. So this is more of requirements from the customer point of view.
Okay, thank you very much.
Thank you.
We have an online question as well. How does changing from steppers to servos influence the speed? So it's a similar question.
Okay. From stepper point of view, you give a step to the motor, and the motor rotates a certain degree. And in a way, you have to approximate. So basically, when you go from this position to that position, you have to approximate how many steps should you rotate. And you can do this with a certain precision. With servos, we don't have this problem because servos have encoder inside, and you can be more precise. Also, you can give to a servo the possibility to accelerate. So if you have to travel a long distance, you can say start from this point, accelerate, and then once you close, or you starting to be close to the end position, then start to decelerate and then stop on that position. So you can do a lot of fancy stuff with the servos, and you can actually improve the whole efficiency of the robot, and the speed, and also the precision of the robot.
Are you planning to do any power and performance measurements on the device while running the tests or the use cases? Is there something planned for on this area?
What we've done, well, I don't have the presentation anymore. What we've done, we left some I/O opens on the microcontroller of the robot. So let's say here, some of those pins are connected directly to the microcontroller, and they are not used. So if you have a specific chip that do power measurements, or you have some other sensors that you want to connect to the robot, you can. The robot for now will accommodate those sensors, and of course we have to write some drivers for those external sensors, but we can integrate to the robot. Okay. Are there any more questions? Yeah.
I'm sorry.
Yeah.
Bloody Americans. How high up does the platform have to be for it to be able to recognize, for the camera to be functional?
Okay, that's a good question. What we've done for this scenario, if I can go back. Here, it's not clear from this picture. We mounted here a camera that has a fixable focal length, so you can adjust this. Depending on how big your device is, you can adjust the focal length of the camera to see the whole devices. Now, what we've done, we made the robot taller, because here you can put some devices under test that may have some wires or things that will elevate the device from the bottom of the robot, and we made especially the robot taller in order to be able to see the whole screen from, let's say, 10 centimeters above the platform itself. So you can put a device that it's this big, so that has the area of the robot, the area of the base, and the camera can see it from 10 centimeters above the ceiling or the base.
Thank you.
Thank you. Any other question?
Maybe if I can comment on one thing on your question. I think, we build the robot from, as Mihai said, from scratch. So we know all ins and outs of it. So today the design, this is prototype. This is the size we chose just to be able to accommodate as many use cases as we can. This one is already bigger because we have a specific use case for it, of course. Now, if you would need a bigger or smaller, it is not a massive problem anyway to change it ultimately. So today Mihai said this is 10 centimeters, or measurements a little bit different. But it's not, I think changing it again, redesigning slightly should not be a massive an effort for us. Yeah?
So that was one of the ideas to actually build the robot from scratch, because you could use a 3D printer and modify it a little bit or buy a robotic arm, but then you don't have control on, or for example, a client will come and say, I want to click on the device in 5 points. Then you should be able to modify a robot to click in 5 points or 3 points, or I want to do this rotation with I don't know what radius on the touch screen. And again, you should be able to modify this according to the customer needs. And that's why we decided to go from scratch from electronics point of view, because then of course you need to know how you should change them in order to accommodate the new versions. And from the hardware point of view, to be able to, if somebody wants to insert a TV screen here. Yeah.
One more question. We have a question from Dragos online.
Yes.
What are the other clients in automotive?
Can I tell this?
Well, no. I don't mean list the clients. What are the other industries than automotive? Where else would it be
automotive.
used? Then automotive.
Not in automotive.
No, other industries than automotive.
Okay. So, again, this demo was done for somebody in telecom area. Then they wanted to test the GSM signals, and in this interesting laboratory that they had, that will be one area. The second area will be for developers if they create an application and they wanted to see how that application looks like on, I don't know, a Samsung and an iOS, or on a tablet, or multiple devices. Also on direction that we found out soon was in banking. For example, for ATMs, you have multiple ATMs with running on multiple hardware versions of hardware, but it's the same software. And when they do a software update, they have to test the software on every single version of the ATMs that they have, and basically anywhere with a touchscreen device. Yeah. So there was a question. Yeah.
One more question. How many actuators are you able to install on this ARM? Because, for example, on iOS, you want to test some gestures, for example. How can you simulate swipe with 3 fingers, for example, or zoom in, zoom out, as you have just one arm?
Okay. Can we put? Yes, I will show. Let me show you directly. I mean a video signal to this laptop, if it's possible.
To this laptop?
Yes.
Maybe we can have a camera showing what's on the laptop.
Okay. So I wanted to show you directly our mechanism and how it works. 1 second. Dacă pot să vin. Dacă pot. Sau hai că rotez pe chestia asta. Okay, so let me see. Yeah. I created a little bit of buzz, sorry. Yeah. Let me see. Perfect. So this is the 3D model of the robot. So here you can see we have two fingers. So this one is fixed, this one here, and also you have additional two that can move. And this one can move on a linear pattern, and this can move on a rotation. And inside, you mount, we have here actually 4 motors inside that are able to move those fingers. And eventually you can add more if needed. Yeah, okay. I wanted to show because it's more clear like that than to actually describe it. Is there any other question?
More questions? If there are no questions, I think we can have a little break. I'll invite you for coffee, maybe drink or something, and then we can come back for our last part of presentation with Bogdan here, who will talk a little bit more of a partnership we have, and there'll be software part of IoT we've been doing. All right. Thank you. I'm thinking we can take a break for 10 minutes till 25 past. Is it okay? 6:25? All right. Thank you. who will talk this time, Bogdan, will talk about asset tracking and usage of IoT devices. Go ahead.
Okay, thank you, Jacek. Hello, everyone. So what at least I will try to present in the following slides is actually the solution that we developed in a partnership with Hanha Limited. Hanha Limited is an UK-based company that is focused on IoT solutions. So I can imagine that any one of you ordered some goods from abroad, and usually these goods takes a lot of time. Sorry, I'm nervous. Takes a lot of time to get to the destination, and I can imagine you thinking about the package, how is it doing, when it's going to get to myself. And as you know, usually most of the carriers shows you the information about the hubs when they are shifting the goods, right? From one hub to another, right? So that can be some information, but for important goods that is not enough, because you want to know how the transport conditions are, like temperature, like thank you, like humidity, all kind of stuff, because you have to think for some very important goods. May I sit down, please? I guess so. You have to think about very, very important goods, like for pharmaceutical goods that are very sensitive to temperature variation, to humidity. Also, you can think about some business critical goods when you really need to receive that good in your office, so you can continue your production process, right? So in this moment, knowing the condition of the goods, it's very critical. So it's business critical. So this is actually what we tried to solve together with Hanha, and basically developed a tracing platform that offers to the user all these transport conditions like temperature, humidity, light conditions. Maybe you want to see if somebody opened your package. Thank you. And even shock control. Maybe the handlers didn't take too much care about your package and it was dropped or mishandled, right? Not in the last, of course, you'd like to know the package location. For instance, this could be very critical for lean production cycles. This is happening mostly in automotive industry, where basically you have to receive, when you build a car, you receive a lot of components from different vendors, right? So you have to, and you cannot afford to receive the goods more in advance, because it generates you some costs in terms of storage them. So you have to be able to, let's say, predict or understand if all the goods is going to come in just in time for your production cycle, right? So again, the location, GPS location is very important. And another thing that this platform, tracking platform is offering to the users is a cloud application where the users are able to see all in live all these parameters like temperature, humidity, GPS location. They can visualize it, they can manage the tracking devices, and some statistics can be generated over the time. And these statistics could be not yet, thank you. Let me say my story. So these statistics could help, for instance, the carriers, because let's say the market for this platform is not actually the end users. There could be the carriers like DHL, like UPS, you name it, right? Over the time, they could be able, using the statistics, to improve their transport routes. So basically, they will be able to reduce their costs, and of course, this is going to transfer for the end user costs. So they will be able to provide a better service at a lower cost. Okay. Well, it works. Okay, so what do you need basically for such a tracking platform? So first of all, since we want it to be worldwide, we will need an infrastructure, and for this, Hanha launched in 2017 a virtual mobile network, which is actually covering 160 countries in the world, and they are basically interconnected with more than 700 mobile network operators. If you don't know, a virtual mobile network operator doesn't have necessarily its own equipment like antennas or I don't know, the base stations, whatever. They are just having some let's call it reseller contracts with a real mobile network operator. One important, let's say, feature of Hanha mobile network, virtual mobile network, is the fact that they adjusted their network to, let's say, be compliant with IoT packet size. So, and I'll try to explain that. Typically, the IoT data, of course, is sent in packets, like IP packets, and typically, a size of such a packet is less than 100 bytes. If such a packet would be charged by a real mobile network operator, it will be charged at a higher rate because typically for the mobile network operators there is a minimum size of the packet that is of a data packet that is charged. So basically, for instance, if you are sending for a sensor like 100 bytes, but the mobile network operator, it would charge you for, I don't know, 1 kilobyte, it would mean 10 times higher than actually you should pay. So this is something that Hanha, let's say, adjusted for their mobile network. A second component of this platform would be some mechanism, actually the sensor, right? So you need somehow to package the sensors and to put all of them in place. And for this, Hanha created an, let's call it a little box, which is something like the size of a packet of cigarettes. I think this is something common. Everybody should understand the size. And that box includes all the sensors for the temperature, humidity, light control, tilt as well. So if it's not kept right, okay. GPS location. Okay, there was something else about that. Of course, it has a SIM card to be registered. Thank you very much. To be registered to Hanha mobile network. And in terms of battery life, this tracking device has a battery which lasts at minimum 20 days, but typically it can record data for 30 days usually. Of course, during the time, all these parameters will be improved because the new sensors will require less energy, the battery capacity will increase, so this will be, I guess, for always work in progress. Okay, and the last component would be actually an application to receive all the data sent by the tracking device. I mean, all the sensors from the tracking device. So for this platform, we went with Microsoft Azure Cloud, and we connected all the tracking devices. Oh, this is nice. To Azure IoT Hub. It's nice. Okay. The data sent from the sensors to the Azure IoT Hub are using the Mqtt Protocol. This protocol is a specially designed protocol for machine-to-machine communications. Why? Because it has a very small footprint of the data, so basically all the headers that this protocol are putting around the useful data are very small, and this is very applicable in the areas where the network bandwidth is not so available all the time, and it could be as well very expensive. From the Azure IoT Hub, all the information is sent further on to the IoT application, where it's stored. The information is computed, the statistics are generated, and as well the IoT application is providing for the users the user portal, where they can see all the statistics. They can as well manage the devices, I mean the tracker. So the user can stop the tracking of the information when he wants, and as well it can restart the tracking of the information. What else can user do? He can define as well some triggers. For instance, if temperature is going above, let's say, 40 degrees, he can say, send me an event when this is happening, so I can take some corrective actions. Maybe deal with the situation with the carrier, or maybe, I don't know, adjusting his production cycles if we are talking about some business critical components. We have as well some, the information is stored in the database, but I guess this is more some internals. There is one thing that I didn't mention about the HANHA mobile network, which I think is very important. The entire network is secured, so all the transmission sent from the sensors is secured in the sense that no public network is crossed by this data, and they are offering as well some VPN connectivity between the tracking device to the cloud application. Okay, so this is the last slide that I have. As you can see, this is the user interface. We have here the temperature, so we have like a graphic how it went through the time, and as well we have the humidity, right? And in below we have the location in time, so how the package traveled in time, right? It's just an example. It's not actually a real use case. In terms of advantages, I think for business critical situations, the user has the possibility to take corrective actions. So his, in this case, lean production cycles will not be impacted too much. Of course, because all this data collection, if anything bad happens, you will know who did it when he did it. So basically, you will be able to fight with the right people, let's say, and recover your losses. I mentioned already a few times transport conditions, statistics available over the time. Again, this could be this could help the carriers to improve their transport path. And again, it might help with the insurance bill, because if you know where you can, from who you can recover your losses, it could be easier for the insurance company to deal with that, I guess, or I hope. I think that was it. Thank you very much. If you have any questions. No.
As I understood, you saw that the battery life is 20 days for this device. After this 20 days, it will involve lots of logistics, like charging all the batteries and so on. Have you thought of using, as a carrier, the LoRa network or NB-IoT, which will give you roughly like 2 to 3 years battery life? They are claiming 5, but let's say 2 to 3 years.
Yeah, this could be, let's say, the next step for this platform. So what happens typically now, it's how it was designed by Hanha for the infrastructure stuff. When the package arrives to destination, the tracking device has a button, you activate it, put it on the postal office, and it's sent automatically back to Hanha, where they replace the batteries, they recalibrate all the sensors. So what you are mentioning about low energy, right? Could be the next step for this platform.
Do you have a follow-up question?
Yeah, it's regarding the price. The price for a LoRaWAN transceiver is roughly €5, just the transceiver. The price for these GSM modules that you are integrating in these sensors is over $20–25. So
yes,
it will be real
cost
cutting using LoRaWAN or NB-IoT, which is quite the same. It's slightly double. It's like €10 the transceiver. I guess it will be more efficient cost-wise.
I absolutely agree. So we have to talk to Hanha and to, let's say, have the next version of the platform using the latest technologies.
Okay. Any other questions? Here we go. Please let me go from the back.
Thank you. What happens to the devices if it loses connectivity? Does it store the data, or?
Yes.
Because it's using a dedicated network, so maybe it's not available.
Yes,
everywhere.
yes, that is correct. So basically, the tracking device has as well these capabilities. So while it is sending the data live to the cloud, it is actually storing as well the data locally. So in case the mobile network signal is lost and it cannot obviously send the data, it can be recovered when the package gets to the destination, because you have all the data stored in the tracking device.
This is more related to the business side of things. So I know that Maersk is working or having a similar platform. So probably Hanha is thinking of selling this on a retail side to consumers, not to other businesses. How's the business model behind it?
No, I think they are focusing mostly towards the carriers, for instance, and other industries like automotive, like pharma industries. I know for sure one of their clients is Bosch. So again, in automotive and for the manufacturing side. So at least for the moment, the price, like our dear colleague here mentioned, the price for the tracking device, it's quite high. As far as I know, it's around €100 or dollars. So it doesn't fit well for the end users, right? But for, I don't know, large carriers, for automotive industry, imagine you have to ship like engines on a big boat, millions of euro. Paying €100, I don't think it's an issue, right? Or even for in the situations where you have to ship very expensive electronics, right?
Yeah, but that ship is usually owned by Maersk, so that's why I'm asking, because they already have this system in place.
I see what you mean, but okay, Maersk is not end user.
Yeah, but
yes,
yeah,
so
exactly. But it's the largest shipping company.
Think if it's on, yeah, when I say carrier, I'm thinking as well like shipping using large boats. I'm not only airplanes or cars or trucks or.
Do we have more questions from anyone? No? We're good. Thank you very much, Bogdan. That will conclude our presentations. However, I'd love to invite you to see maybe how the new version of Mqtt comes along as we speak. And then, meanwhile, our colleagues prepare some food and we can continue networking and having some nice time. Thank you, and please, stop by.